Involved in this session via ICOLD Committee L. I'm the Young Professionals representative for Australia on that committee, and was quite excited last year to hear the idea to put this together. Over my career, I've developed a pretty young and vibrant tailings team, working at Rio Tinto Iron Ore, where I lead the tailings program. We've got a vast array of speakers today covering a lot of the different points of views and specialties in the tailings industry, ranging from environment closure, a couple of career retrospectives, and also a lot on professional development, looking towards the future and resources that can help us to do that. You will note there's no specific technical topics in perhaps a geotechnical or hydrotechnical field. That's deliberate, but at the same time, I'm hoping some of the talks touch on those enough for those with a technical background. I think anyone that works in the dams or tailings industry specifically would agree. We work with a lot of interesting and often highly motivated people. I think we've got a panel covering that well today, and I hope you really enjoy the presentations. And before I forget, thank you to all the presenters for volunteering your time. We could just move on to the agenda. So we'll do a quick round of introductions while the agenda's up there. I'll allow you to run through it. We'll go in order. So Andy.
Yeah, so good afternoon, good day. Andy Small, I'm the chair of the ICOLD Tailings Committee. I'll provide a more detailed introduction to myself in a moment.
Thank you, Andy. And Tamie.
Hi, good morning. I'm Tamie Weaver. I'm a partner and technical fellow at ERM and a hydrogeologist by specialty, working in tailings.
Thank you, Tamie. Before I jump to Fernanda, I'll say we are having some technical difficulties, and that's impacted you more than anyone else today. You've only just been able to join the call. Please introduce yourself.
Hi, good morning, everyone, or good afternoon, good evening. I'm Fernanda. I'm a Tailings and Geotech SME for Rio Tinto. Thank you.
Thank you, Fernanda. And to Len.
Yeah, hi, Len Murray. I'm currently chairman of the Klohn, Crippen, Berger board, past president, and I've got a 50-year career in tailings that I'm going to condense down to 20 minutes. Looking forward to it.
Good luck, Len. Thank you. Madeline.
Hello, everyone. My name is Madeline Sova, and I'm a geotechnical engineer with WSP in Denver, Colorado.
Thank you. Chris.
Hi, everybody. I'm Chris Bereither. I'm associate professor in civil and environmental engineering at Colorado State University, focused in all things geo.
Thank you. Matea.
Hi, everyone. My name is Matea Klohn. I'm a researcher at the University of Ljubljana. I'm the current chair of the Young Professionals at ICOLD.
Thank you, Matea, and I've already introduced myself. Before we kick into the presentations today, a few matters of housekeeping. The question and answer will be at the end of all of the presentations. However, please feel free to add any questions as you think of them into the chat. I'll just repeat, not the Q&A bar at the top of the screen, but the chat bar, and then we'll have a moderated Q&A at the end of the session. If you like anyone else's question, please place a thumbs up on it, which you can do by hovering over it and hitting the little thumbs up icon. With no further ado, let's jump into the introduction, and I'll hand over to you, Andy.
Okay, yes, so good day. So I have about 35 years experience in the industry. I'm a geotechnical engineer working with Klohn, Crippen, Berger, based in Eastern Canada. I'm the chair of the ICOLD Tailings Committee, and I'm very proud to announce that we've just issued a bulletin in January this year. I'm going to share my screen with you for a moment to show you what I mean. This bulletin, preprint 194, is available on the ICOLD website. And this is a very, very significant bulletin. It's the first bulletin of its kind that gets into the real meat of tailings dam safety for all jurisdictions around the world. Previous bulletins, when we've written them in ICOLD, we've always had to go to the lowest common denominator, and they've been a bit watered down and a bit general. This one gets into very specific guidance on issues such as design floods, factor safety, and so on. And it's got a lot of information. In fact, 2 comprehensive appendices on slope stability and dealing with contractive soils in particular, in response to the failures that happened in Brazil. From a young professional's perspective, this is a very good read. If you want to get your head a bit around tailings facilities and what we deal with from a technical perspective, this would be a very good read for you. My job in ICOLD over the past year has been to promote this bulletin. And we've got the message out in a number of areas: Marseille, Budapest, Montreal, Kazakhstan, Tajikistan, Brazil, and others. And, we need help. We need help in terms of educating people about what's required to create safe tailings dams. And we need capacity and capability of bright young engineers to come in and make sure the right things are being done. So we're really pleased to have you join this webinar today. We know that many of you are either involved in the design or safety assessment of tailings dams and you have an interest in this field. So we're really pleased you could attend. You're going to hear later today about the significant demand for tailings dam safety engineers that are in our industry. We need quite a number. And we're trying to help you understand that going down the tailings dam world is an excellent career path. And there was a concern in the past about exposing young engineers to undue risk. That's not the case these days. Every one of the consulting firms and mining companies that are involved in tailings dam safety engineering are committed to protecting the young engineers and the staff that are involved in their projects, because they know that's the right thing to do. So our goal is during this webinar to tell you about tailings, what it's like to be a tailings dam safety engineer or work in a related discipline, and how we can develop the next generation of tailings dam engineers. Our Jared Coffey, he's assembled a great team of the 7 presenters, and you saw that in the introduction earlier. And on that note, I'm going to turn it over to Tamie Weaver, who will be our first presenter talking about tailings and the environment. Thank you again for attending today. I will be moderating the chat and be feeding the questions out at the end of the presentations.
Thank you, Andy. All right, so hopefully you can see my screen. Tailings and the environment. So today I want to talk about tailings and the environment. And unlike most of you, I'm actually not an engineer. I'm a hydrogeologist. I've been working in groundwater across a range of industries all my life, but have been working in the mining industry throughout my career. And over the last 5 years, particularly to 10 years, we've seen this increased focus on the performance of tailings dams. So when we talk about tailings, what do we mean? We mean those fine-grained gangue minerals that are derived from the process plant, any process chemicals that are in the output from the process plant, and then the water that's used typically to slurry the tailings. And that could be groundwater, surface water, or other on-site water sources. In terms of safe disposal and management of tailings, there are multiple ways of doing that. The most common, though, is the above-ground tailings storage facility, the tailings dams that most of us are familiar with and most sites deal with. However, some sites have in-pit or in-workings below-ground tailings storage facilities, and also in-river or marine discharge. And this is predominantly a historical practice, but still there are lots of sites where that's the case. The focus on tailings management has really come to the fore with the GISTM in 2020. And I just want to bring the key proponents there, the key comments there to the fore of zero harm to people and the environment and zero tolerance for human fatality. Over on the right of this slide, you'll see that I've put a range of stages for tailings facilities. And that's because if we're going to protect the environment and reach this goal of zero harm to people in the environment and zero fatalities, we need to be thinking about these facilities through their decades of life, from PFS and feasibility studies through to post-closure. All right. So here are a couple of pictures. This is the King River in Tasmania, where tailings were disposed down the river, and we now have a 5-kilometre wide delta of tailings in a harbour. This is an in-pit tailings facility, and this is a more typical facility taken from ICMM that sits within a drainage valley. Okay, so if we go back to that concept of zero harm to people in the environment, we have to acknowledge that this objective applies to communities, ecosystems, and the associated environment around and downstream of our tailings disposal facilities. So we're thinking about land, including dust, surface water, and groundwater, and how people and ecosystems interact with those aspects, those segments of the environment. I want to talk about adverse impacts, and many of you will have front of mind the breach or failure type of impact, where the tailings dam actually fails. And this is where the fatalities happen. This puts workers, downstream communities, downstream waterways and ecosystems at immediate risk and long-term harm. So there's immediate human health and environmental impact, absolutely the potential for fatalities, as per the most recent ones, I think in September last year. But also these, even after cleanup, these lead to longer term environmental and human health impacts, where the tailings have inundated creeks, they've changed the sediment characteristics, they've inundated land, and there's ongoing seepage to groundwater and surface water, and ongoing uptake by flora and fauna, and therefore the communities that rely on that flora and fauna. I want to focus on what most of my work has been focused on, which is the long-term performance of tailings facilities. I seldom get involved in a downstream breach. It really is looking at the long-term environmental performance of these facilities. So assuming they're stable and they stay up, we still need a facility that does not pollute the environment and cause harm to the environment. And again, we're considering dust release and off-site deposition of dust, surface water runoff and seepage to groundwater and down gradient groundwater flow. We need to consider that these sites evolve and expand through time. And so we need to, and they evolve into both space, but they evolve in their chemical characteristics of the tailings. So many of these sites, like I said before, are decades scale facilities. So the tailings and decant composition may change and be transformed, might be different grain size, might be different composition. Tailings may oxidize, you may get salinity buildup. You're going to need to monitor for dust and the composition and mobilization of that dust, and for surface water and groundwater, both in terms of levels and quality. And then we need to evaluate those data against the relevant environmental standards or background conditions for our facility. Specifically for tailings, we'd be considering salinity, acidity, metals and metalloids, radionuclides potentially, processed chemicals such as cyanides or thiosalts, and other chemicals. And I have put per and polyfluorinated fluoroalkyl substances, the PFAS substances here, and hydrocarbons. But PFAS is something we are seeing materially in mine facilities around the world. So when we talk about environmental monitoring, it needs to be adaptive, both to address the time scale of which these facilities operate, but also to address that over those decades, our technical understanding of facilities changes. As to the contaminants we look at and how we understand them, climate is changing, environmental regulations change, and community expectations change. And they are going to become more stringent, not less stringent through our careers. So questions we need to ask are the TSF walls or floors acting as a barrier to seepage to groundwater or surface water? Are there areas where seepage is apparent on and beyond the walls? Is the seepage from the walls or is the seepage from the tailings? What are the controls that affect the impacts to groundwater or surface water? And is surface dust sufficiently controlled? And what are we using to control that dust? And what are the implications of that? So for all of your facilities, you should have extensive and robust groundwater monitoring wells, surface water monitoring sites, level and electrical conductivity loggers so that you can capture seasonal and temporal variability, visible indications of seepage. We need to monitor for visible indications of seepage and evaporation and buildup of salts, and we need to monitor for dust, all with the goal of protecting ecosystems and the supporting communities. Okay, so to summarize, when thinking about tailings and the environment, we need to consider meeting these environmental objectives and monitoring the performance of the facility from PFS through to post-closure. So we're talking about decades. The monitoring program needs to consider people and the receiving environment and how that changes through time, and see it as a tool to assess performance of the facility, not just compliance. Is our facility working the way we expect it to and need it to? So the monitoring directly informs risk management and remediation. And as I mentioned before, it needs to be adaptive to meet changes that we're seeing throughout the life of these facilities, particularly with respect to climate change and variability, emerging contaminants, our technical understanding, and the expectations of the regulators and our communities who live downstream. And with that, I'll pass on to Fernanda. Thanks.
Thank you, Tamie. I'll start sharing my screen. I think your presentation is, well, my presentation is a good segue to your presentation, Tamie. It's very good to see how you're thinking about the future. And so I'll be talking about closure of tailings facilities. And this is actually a quite new subject, even though we've been closing dams for over 100 years now, but having closure as a discipline is something quite new. So what will be the topics that I'll be showing in my presentation is how not thinking about closure when we were designing or operating the facilities can lead to interesting challenges in the future on how to mitigate those environmental impacts and ensure that the facility can be self-sustainable once it's completely rehabilitated. That's why I changed the title of my presentation to Not Designing for Closure. I'll be showing a series of examples of what we shouldn't be doing now to ensure that facilities can be safely closed in the future. So as I mentioned, why to design with closure in mind? It's really to reduce the impacts of cost impacts and engineering challenges when we are thinking about closing the facilities. I'll be giving you two good examples of closure objectives, and these are mine closure objectives. They are not only tailings facility closure objectives, but they were extracted from two mine sites that do have several tailings facilities. So this one has 4 simple objectives: safety, stable, non-polluting, and able to sustain an agreed final landform. So if these objects were set in the beginning of the design of those tailings facility, achieving these objectives now would be much easier. I just want to call out to the long-term stability and rehabilitated areas and non-polluting. This is something that Tamie was talking in her presentation. No long-term impact on environmental values or unacceptable human health risks from non-contamination source and pathways. Just keep those two in mind because I'll be talking about them in my next slides. And the next one's from another mine site, also here in Australia. And the objectives are to safety hazards have been appropriately managed for the long term. Water quality and flow does not pose an unacceptable environmental risk. Contaminated sites have been effectively managed. The final landform is in a stable condition that minimizes long-term environmental impact. So you can see closure objectives for different mine sites in complete different areas. They all talk about the same thing: is how can we give this land back to their owners in the safest way? And this is the objective of any closure department, any closure specialist. So this is my first example of what not to do. So this is The tailings, this is a tailings facility that started to be built 200 years ago, and it was initially closed 40 years ago. And to allow the construction of this facility, they moved the creek that crossed this facility in the middle to this blue line, to where this blue line that I've drawn on the picture is now. The problem is that that blue line is right at the toe of that tailings facility. Okay, and that blue line also coincides with the permitting limit of that facility. So it means that you can't construct anywhere, you can't move that creek anywhere further to the west, because the land in the west doesn't belong to that facility. So what types of issues that we have in this facility nowadays? To achieve the final stability, instead of flattening the slopes, we're gonna have to adopt a more expensive solution, which is stabilizing those walls with rock, because we just don't have land to flatten those walls. So what could have done better? First thing, site selection. If we can avoid selecting a site where there is a creek, the creek not only is a problem because you need to deviate that creek, but the creek can also bring a risk of foundation liquefaction because of the type of material that you usually have in the bed of that creek. So if you don't really clean that creek well, you do have risk of liquefaction of that foundation. So if you only have the option to build somewhere with the creek, just make sure that that creek will be very far away from the final landform of that facility. So when we are initially designing the facility, keeping the final landform in mind is very important to avoid this type of issues. And this type of issues of just building on the limit of the permit is common in, I think, almost all mine sites nowadays. The next example, this is another facility. And what you're seeing here is a study that looks at this facility closed 50 years from now. And what it shows, the red, orange, and yellow colors, they show the areas of the tailings facilities that will still be saturated in 50 years from now. So it means that tailings still have potential to seep, and we'll still have to treat that water in 50 years from now, okay? So what happens? This facility was built very close to the sea. Parts of that facility was built in the terrain that was below sea level, and part of those facilities had their floor excavated to allow the construction of the embankment. So they brought the floor of the facility to below groundwater level. Okay, so, and back at that time, this facility is 50, almost 60 years old. Liner wasn't really something that was considered to all facilities. And in this case, they thought that groundwater could neutralize the leachates from this facility. So that the solution was just to excavate and place the residue there without any liner. So what problems do we have now? We do have a long-term leachate treating problem. As I mentioned, this figure shows a scenario in 50 years from now. And it's just a facility that for closure is quite difficult because the terrain can be quite saturated because of seepage. So we do have construction challenges in this facility as well. So once again, what could have done better? The site selection. The main driver, we believe, for the site selection was the proximity to the refinery. And this was not, I mean, if it was done nowadays, maybe we would have considered something different. And also, if they had considered liner, we most probably would have less issues with groundwater contamination. And then this is another one. This is an interesting one because it's not about site selection. It's about a decision that was taken during the construction. So they were constructing, they were building the core of the embankment, and they found two springs. And they decided that they had to deviate that water from those two springs to allow the construction and the good compaction of the dam. But the issue is that that deviation line was not registered in any as-built. So we have two photos of this line. One is this one that I'm showing, and then there is another one in the construction report, but there is no as-built of this line. And the methodology used back in the 90s is not something that we use anymore nowadays because of risk of piping. So we're developing a solution to try to monitor this risk and ensure that this facility is safe and can stand in perpetuity. So again, what could have been done better? Development of as-built of the new features, even if it's a construction feature that won't be used for the performance of the dam in the future. It's very important to have any modification registered somewhere. And clearly document construction method. So we are unsure on how the material was compacted around this pipeline. So that's why I mentioned the clear document construction method. And finally, I'll talk about legacy sites, which is, so these are sites that are usually the companies, they inherit the sites, they've never operated it, they didn't really close it. And usually the documentation, it's really poor. So as you can see, this is an example of a typical cross-section of a dam that was done in '86. And this specific dam was built in the 50s. So it's already an interpretation of what has been done in the 50s. So usually when we get these legacy sites, we get a black box. We don't know what is inside. We don't have the documentation. There is very poor history. Most people that worked on those dams are not alive anymore. And usually these facilities had several consultants, most of them closed along the year. So it's really hard to get that information. So you need to build information about those facilities through geotechnical campaign, topographic surveys, and observation. And another challenge that we usually get with this facility is that sometimes they don't even belong to the company anymore. You only have the liability of that facility, but you don't really have access to that land. So everything needs to go through permitting processes, and it can take much longer than in a site that's owned and operated by the company. The other challenge with these legacy sites is that usually you have stakeholders, external stakeholders, the community, that don't even know that those dams are there. So you need to create a communication plan to make the population aware that they are living close to a dam that could present risks, and how the company is making sure that those risks are being managed, even though the facility itself is not owned by the company anymore. So I hope I've stimulated you a little bit to look at working in closure projects with, we have a lot of challenges, and the challenges won't stop. I guess for the next 20 years, we're going to have very interesting challenges in the closure area. So I'm passing to the next speaker now. Thank you.
Yeah, it's going to be me, Len Murray. I'll try and share my screen here. Hopefully you can see my screen, and I'm going to stick on this view because then I know what's coming up, and also you can look back at slides if you're interested. So I'm going to talk about my career, which is mostly in tailings. It's now spanning almost 50 years. That shot you see there is of me, a younger me, with my middle daughter there, actually at Octetti Mine, and I've been fortunate enough to have a few family sort of long-term assignments at various mines. Needless to say, Ellie didn't go into mining, despite the fact that I took her to some scenic spots there, obviously. So my career actually started in 1975, the end of 1974. So I'm coming up to 50 years. And I wanted to show a little bit and talk a little bit through this presentation about larger forces in society that maybe change things as you go along in a long career. And what you see here is a plot. The vertical blue lines are recessions, And I started work right in the middle of this recession in 1975. I went to Canada in the middle of this recession in 1981, and back, I was in PNG through this time here, back to Canada in 87, and so on. Each of these recessions up to about 2001, the company I worked for, which is Klohn, Crippen, Berger now, really had a tough time, and there were a lot of layoffs in the industry, not just our company, but generally. And it's hard to imagine now with all the demand for people in the mining sector that could happen. But life seemed to change in 2001 with the World Trade Center, where the mining industry really took off. And apart from a few minor blips around maybe 2014, the demand for people has far outstripped the number of projects. So it's been a really good time for technical staff, but that doesn't mean to say it's going to go on forever. So I think people need to factor that into their life. So I started work in the UK, and a lot of my work was small scale infrastructure, little slides like this, and roads and bridges and foundations. I'm basically a geotechnical engineer. And believe it or not, when I started work, I was using a slide rule. I don't know if people are familiar with slide rules, but Google it. You can do anything on here pretty well that you can do on a hand calculator. It took about a day to do a method of slices, slope stability analysis with this instrument. Obviously a downside there, but the upside is that you get very good at understanding where the critical slip plane is, because you don't want to do that twice. And the other aspect of this is, this was invented in 1640, I think, by this handsome looking fellow here, William Outred. And when you think back, I mean, I started work with a 400-year-old piece of technology, and how many people in this day and age are probably using stuff that's 5 years old? I mean, if you are, you're probably already out of date. And I think that's one big change, is that, well, yeah, the pace of technology. And I mean, it's just stunning how fast the change is and that we have to adapt to. The other good thing about, not having such fast computers and things is I relied a lot on sort of hand calculations just to check what I was doing. And this is a simple infinite slope equation down the bottom, but there's many equations for pretty well everything you'll do as a geotechnical engineering geology type person. And I heartily encourage young people to check their complex calculations as much as they can with hand calculations. So I moved from the UK, and I joined what was Klohn Leonoff then, now Klohn Crippen Berger, in 1981, right in the middle of that recession. And this is the previous generation who were the managers when I came into the company. And I think you can see a lot of things have changed there. I mean, the health and safety procedures there, I think this is enough to turn any health and safety person grey. You can't see these guys falling in the water and surviving with those little life jackets. And also, this is one of my favorite photos of a guy called Charlie Ripley. He's in his suit. I think he's got a tie on there and a nice hat, and he's walking around in the middle of a hydraulic fill there. And that, I guess, epitomizes the spirit of that generation. They were very much pioneers, and geotechnical soil mechanics was very much a pioneering field at that point in time. So when I started my career, this is basically the cohort, and just a few of them that I went through most of my career at Klohn with, and this is what they look like at least a couple of years ago. And the top there is what they looked like when I started and when they were starting. And I guess the point I want to make here is that it's really important, I think, as a young engineer, to look around at the people you're working with. Like, I mean, it's not obvious that the guys at the top of the photo would, all become fellows of the Engineering Institute of Canada and high profiles in most of the professional societies that we know of, from the when they were young, because obviously they haven't developed their career then. But I think we always had the sense in our group that we were pushing each other to be better at our chosen profession. And I do think it's worthwhile people just looking around in their careers and saying, who are the people I'm working with? I guess now this is more the modern generation here, and the obvious difference is a lot more women involved. I think the diversity there is, it's still not perfect, but it's a lot better than it was. Certainly when I started, there were no female engineers, and this is just a cross section of the Canadian part of our company, and a good looking lot of people they are too. So I just want to change gears a little bit now and talk about some of the formative projects in my career. And I think what I have become aware of is that as you develop your career, you are what you what you've worked on to some degree. And as I said, when I went to Calgary there in the 1980s, 1981, there was a massive recession in the oil industry, and really the work wasn't there. We were on a 3-day week half the time, but the company, partly because of that recession, the senior people in the company were available to go out to Papua New Guinea to the Oktedi mine and try and help them with their tailings management issues. And then I was available as a younger engineer to go on. I lived there for 3 years with my family. There's quite a lot on this slide, but I guess for the people who know the mining industry, there's still no tailings dam at Oktedi, but there is a dredge sand scheme. But one of the reasons there isn't is down the bottom left of the slide here. The original tailings dam was to be built on an area of high plastic shale foundations, which in that environment, these are slaking materials and they form a muddy colluvium deposit. And coming from Alberta, we knew all about high plastic shales, very low friction angles. And during the excavation for the foundation for the tailings dam, that triggered this a massive regional slide here. Now I want to contrast that a little bit. This is an area where the natural shale deposits, and you'll just see some limestone appearing at the top of the section. Well, a big feature of the Oktedi area, and you'll see this, the spine of Papua New Guinea is a mountainous region, but it's this Hindenburg Wall, which is several hundred meters high of karstic limestone. And sort of post-glacial times, 10 to 8,000 years ago, there was a massive failure of this Hindenburg Wall, consisting of several cubic kilometers of rock, which basically crushed itself down into sand and gravel and spread out over a large area of the site. And you can see from that, how interesting that was for an engineering geologist like myself. I got into geotechnical engineering from that side, where this large rock avalanche slide had deposited over the shale. Excuse me. The area was relatively stable because it blanketed this muddy colluvium, and you were able to build things on it. So one of the features of this job was when we got to site there, we went out to build a new tailings dam, and we did find a decent site south of the old Okmar dam site. But at that point in time, the mine decided not to build a tailings dam, and it's been doing riverine tailings since 1983. But at that time also, they had an idea for a mini hydro scheme, a 50 megawatt hydro scheme, and the people who were there, who'd gone out there to build the tailings dam, like myself were put onto the hydro scheme. And I think one thing, one lesson there I want to bring to people's attention is that the skills that you have for tailings dam work obviously are transportable, and working in the mining industry, you never know what's going to come up, whether it's hydroelectric work or bridges, roads, railways. There's all sorts of opportunities there if you have the right skill set to take on anything. And I just wanted to, this is my second last slide here, but just go and touch on a few of the projects that have been landmarks for me to give you a sense for the type of variety you get in the mining industry. So these top two photographs are that Octetti site I was talking about, and this is the intake to the run-of-river hydro scheme. The middle picture here was taken about 5 years after construction of this intake weir. And what you can see here in this photograph, I hope it's a little bit dark, is this abutment here is cut into that limestone colluvial landslide. And just downstream of this relatively stable area here, the river has actually cut down through that slide material and exposed the muddy, weak 10-degree friction angle or 50-degree kPa colluvium. And you can see how through that down cutting now, the upper colluvium there has lost its toe support, and it becomes very ragged, and basically it's all failing into the river. And just understanding the engineering geology of that situation, we were able to go in and build this intake, with a rigid concrete structure in a safe environment. And this is in 1990. I think this is a picture taken in last year where this weir is still operating. It was commissioned in 1985. It had a 20-year mine life. It's now 40 years into that 20-year, design life. And you can see the abutment there is still quite stable. And just that thorough understanding of the engineering geology is really, what I think we lost sight of a little bit. And a number of these failures that you've heard about have been part of that. This is a water dam in Vancouver. It's called the Seymour Falls Dam. It's immediately above West Vancouver, a very high consequence dam. This was a earthfill structure which we had the job to rehabilitate, and it was on also on a landslide actually, but this one was loose, and we compacted the landslide material with a combination of explosive compaction. I think we blew up something like 5 or 10 tons of high explosive in extremely controlled manner at the toe of this dam, and then went back in and did dynamic compaction. So this was a highly monitored piece of work, because as you can imagine, if we'd blown up this dam, it would have killed probably 100,000 people. So, and again, you get confidence by doing things like that and coming up with these monitoring plans and working on it as you go forward in any sort of earth structure. This project down on the bottom left here, this is the Greens Creek mine in Alaska. So we've gone from New Guinea to British Columbia to Alaska. And tailings, a lot of tailings is going this way now, but this also has its challenges. This is on a glacial terrain, and there's a lot of engineering geology challenges, including a bit of a surprise valley through the middle of this site that's filled with very loose material, and again in a high earthquake zone. I've worked on this since the mid-90s, and real good understanding of how to place fine material in wet, cold environments, and and also how they perform. This site here is the Hidden Valley site in Papua New Guinea, and a lot of what I learned in PNG and these cold, wet, warm, wet environments. This dam here, which is called the main dam, is also on a landslide. This happens to be on another rock avalanche landslide. It's dense. So this dam is very stable. The other side of the impoundment, which when we started, there was no such thing as LiDAR. We thought this was going to be a 5 or 10 meter high dam. By the time we got proper topography there, this is now a 60, 70 meter high dam on potentially liquefiable ground. So we've been doing a lot of work making sure that dam is stable in the event of an earthquake. And that is one point that, again, I'd like to make with tailings dams, which makes them so fascinating. And Fernanda touched on it. You build a tailings dam close to the ore body, and maybe not, you know, as close as these days as you would, but you don't always have a choice for the foundation, and that makes it really interesting from an engineering, geology, and a soil mechanics, and all of those points of view. Just to show, you know, another cold environment. I won't go into too much detail here, but this is in north of the Arctic Circle, and you can imagine the challenges there. And this one particularly now, we're designing with critical state soil mechanics in mind, and so on. A shot here in the Atacama Desert. This is actually Escondida, and for this particular site, the main challenge was water recovery. So I had to learn a lot about unsaturated soil mechanics and water release as you deposit hydraulic tailings over a several kilometer long beach, evaporation, seepage, and water recovery. So the dam itself was not that difficult, but the, you know, understanding the unsaturated soil mechanics and water recovery side was very interesting. And lastly, this is just a dot map of where I remembered I've been in the last 50 years. Somebody told me to take my holiday snaps off this, but these are all sites, vast majority of mine. I think they're all mine sites actually. But you can see the range of areas you can get into through a long career in mining, and each one of these dots has its own challenges, often local differences, ways of doing things that you can then take the good and forget the bad, and bring the good to the next site there. And that's me in a younger version. And like I say, I mean, for the young people, I really hope you enjoy your career and don't get bogged down too much in, you know, in the day to day, because, you know, it's a great career to be. And I have no idea who the next speaker is, but I'm going to pass it over to the next person.
Thanks, Len. Maddie, you're up next. I'll hand over to you.
Yes, great. Thank you. Hi, everyone. My name is Maddie Sova, and I'm a geotechnical engineer with WSP in Denver, Colorado. Thank you to all of the presenters so far, and thanks for joining in today's webinar. Today I'll be presenting on the implementation of the Global Industry Standard on Tailings Management, or GISTM, and I'll offer some of my personal perspectives as a developing engineer within this context. Just as Len alluded to, this is a global industry, and so there's lots of opportunity. Today, I'd like to cover a variety of topics and squeeze a lot into my 10 minutes. So to set the stage for the presentation, I'll briefly introduce GISTM in the global context. Then I'll summarize some research completed by Colorado State University graduate student Louise Spencer and her paper published in 2022 on the number of persons needed to fulfill the requirements of implementing GISTM. And reflecting on this context, I'll provide some additional perspective on my career journey so far and a hopeful trajectory towards an aspiring EOR or engineer of record. So who am I? Why am I presenting to you guys? I'm Maddie Sova. I'm a graduate of the University of Wisconsin-Madison, and I've been working with WSP for about 5 years, formerly Golder Associates. As a consultant, I've been able to travel to a lot of cool places and meet a lot of brilliant and motivating folks. And I'm just really grateful to be working in an industry that's adaptive and engaging, and glad to be joining in the Young Engineers Forum as a young engineer myself. And I hope I can connect with you guys in the future at different events. So let's jump right in. Just last week, the UN News published an article with the headline, "A livable future for all is possible if we take urgent climate action." Climate change, sustainable infrastructure, and clean energy sources are not new topics, but how does this change come about and where does it start? I believe that's this government backing and a political will for the change that'll be our ignition. And GISTM is just that. It's a compliance standard that's now driving our industry and tailings specifically to change. There's no longer a want for mining industries to present their environmental, social, and governance, or ESG indicators, but a need. And lack of change is going to result in limited availability for responsible investment and stakeholder backings. Mines that are members of the International Council on Mining and Minerals, ICMM, have a deadline for this change as well. Mines have committed to ensure compliance with GISTM by August of 2023 for tailings storage facilities, or TSFs, with extreme or very high potential consequences, and all other facilities not categorized as such must be adequately closed or compliant by August of 2025. Okay, so what's it going to take to implement GISTM globally, and how many TSFs are there globally? How many people is it going to take? Kind of sounds like I'm going to be busy. Some research published in 2020 by Hatton et al. And in 2021 by Spencer et al. Developed estimates for the number of tailings storage facilities worldwide and the number of people to implement GISTM at these facilities. Updated estimates for the global Global Tailings Portal records that there's approximately 2,000 TSFs worldwide. And research completed by Hatton et al. In 2020 estimates that it could be around or even greater than 17,000 TSFs. So is it 2,000 or 17,000, or is it even more? There's still a lot of uncertainty in these estimates, but the question still remains, do we have enough people to do the work? The research published in 2022 by Spencer et al. Indicates that if we conservatively set the number of tailings facilities to 17,000, the number of people needed to fulfill these roles is around 13,000 to 19,000 people, and that includes even supporting roles such as project engineers and staff engineers, which are not explicitly outlined in GISTM. So it's quite possible, and the research suggests that these values are conservative. Some TSFs may require more time and resources than others, and others require less. We see and we know that the individual roles presented here are supported by a team of engineers, scientists, technical experts, and a skilled workforce. So who's going to do the work? Quite honestly, this is kind of overwhelming data, but we see the numbers. There's a lot of TSFs, there's a lot of people needed, and where do I fit into this mix? I've had about 5 years of experience in the industry as a consultant, with lots of time spent in the field doing drilling projects, construction quality assurance and monitoring, and also time in the office, running models, writing reports, and performing calcs like I'm sure many of you have, and time outside of work as well, participating in conferences and professional organization events. Do I have all the tools and resources I need to fulfill the roles that are outlined in GISTM? If we look back at this table, I fall within the bucket of a project or staff engineer. And assuming I continue on my current trajectory, it seems like the role of engineer of record could be something I could aspire to. The GISTM framework and associated guidance documents recommend approximately 10 years of experience is needed to take on this role. But what is the role, and do I even know what the required responsibilities are? Both those tangible, the ones stated in GISTM and guidance documents, but also the intangible aspects of the role, such as communications and some of the soft skills needed. Earlier this year, I performed an internal survey within my group at WSP to see if others understood the role. Out of 42 respondents, the average rating on a scale of 1 to 5, 5 being complete understanding, was about a 3.75. And I think I fall within there. I know the rules or the responsibilities outlined in GISTM. But with all the guidance documents and frameworks and personal interpretations of the role, it can feel like a lot to sift through. And I know that they've been authored to provide clarity of the role, but it's easy to feel like it's bogging down the essence and even mystifying it a little bit. Some of the demographics of my survey respondents are presented here. Approximately half of respondents currently serve in an EOR or deputy EOR position. And of the respondents, 30% indicated that they were not prospective of an EOR or deputy EOR role. Can this be attributed to the lack of understanding of the role, or is it other factors? I didn't specifically research this finding, but it could be an interesting question for you all to pose to yourself and your colleagues who are interested in any of the roles outlined in GISTM. WSP and many other industry professionals recognize that an EOR may not be may be one designated person, but the EOR is supported by a team. And I don't really believe that the 30% of respondents not interested in being an EOR is a negative statistic, but rather emphasizes that the EOR is supported by a suite of multidisciplinary professionals. I know that I'm not quite yet ready for the role, but based on the mentors I have that are EORs, I'm confident it's something that's achievable. I believe that focus on succession planning should begin very early on in an engineer's career through thoughtful mentorship and a defined development framework. A successful succession plan can promote early identification of high potential successors and will facilitate more formal conversations around the roles. It'll also provide a development framework for those who are aspiring for the role. If you're anything like me, once you have a goal, it becomes tangible and achievable. I would encourage both developing professionals and those who serve in the GISTM outlined roles to actively participate in more conversations to demystify the positions. Effective communication and trust are essential for building strong mentoring relationships, and it will motivate my peers and myself to drive the change needed for safe tailings facility management. I hope that this presentation will prompt some more active conversations for succession planning and will encourage developing engineers to gain a breadth of experience, seek out mentors, and make transitioning into these roles as smooth as possible. And now I'll hand it over to Dr. Breither to present next.
All right, thanks, Maddie. Great, nice segue. Hopefully you can all see my screen. So Amanda and I coordinated, knowing what she was going to talk about. So I'm going to go on a presentation here about developing the next generation of tailings engineers. Now I am an academic, so this is coming from an academic perspective, and it's really food for thought and seed of conversation. So if we're going to develop engineers, what do I think we need? I think we need investment. And I think we need investment in dedicated time to educate and mentor the next generation. And also we need money. And because no one's just going to voluntarily fork up their money when we want them to come into our career path. So I think we need to invest in people. And I think this investment is really needed over the next 10 years. So the basis for my discussion that I'm going to present here in the next like 8 to 10 minutes, we know our future is going to be rich in tailings, right? There's been numbers floating around. If we look at this graphic, which some of you have probably seen, this is looking at about 8,500 tailings facilities. The cube here is an estimate for all the tailings stored in that number of facilities. And then the drop is looking at the approximate size of growth. We know that's increasing because obviously our ore reserves, the grades are decreasing and we need more minerals. So we know it's going to be rich in tailings. Looking at the appropriate estimate, we'll build off what Maddie was saying. And a couple of kind of rhetorical questions. Should all tailings facilities be required to improve? I'd say yes, right? We want everything improving in the future. Do all facilities require the same amount of resources? No. Some require more, some require less, right? But all require human resources. So what is the currently available workforce? And then what's the required workforce to serve the facilities? So just leveraging a couple data points from Maddie's talk to move forward, right? We had about in the Global Tailings Portal, these are publicly disclosed ICMM members and others who are voluntarily disclosing. We're at about 2,000 TSFs. From the study that a former student of mine, Louise Spencer, did, we estimate about over 17,000. You'll see Andy Small mentioned in the text. They had a group that are estimating above 25,000. So we know there's a lot. Building off these numbers then that Maddie also presented, I'm just going to focus on two things here, right? If we look at the amount of labor need to serve, the 2,000 that we currently have, let's assume we have that number, right? Let's assume these numbers of people exist and that we need to build up and build more capacity. So let's just take these other numbers as reference here. And regardless of how we look at it, what's the actual right number, we know that there's a gap. And I can feel this gap all the time because my students that are graduating in the past, maybe they had like 1 or 2 interviews. Now they have 8 to 10 interviews and they have offers from everyone. Everyone's hiring, everyone's looking for people. Some companies are turning down work because they just don't have the people to do it. So we know that there's a demand for people in the industry. So what I want to focus on right now is engineers. So I'm in the position of education, educating engineers. Most of the students working with me actually go out and work in mine waste groups in consulting and in industry. So if we look at those numbers again, right, and we're just looking at the numbers of project and staff engineers, right, we need those engineers first, because if we're going to build up to, say, RTFEs, to EORs, to ITRB members, right, those are going to need training initially. So if we don't bring people in from the bottom of the pyramid and we don't build that stable base, we're not going to have enough people to move forward. Right, so we need these people. And so if we just take these numbers as they are, right, we need an additional, let's say, 3,000 project engineers and 4,500 staff engineers. We obviously don't need those right now, but we need a lot of engineers moving forward in the future. So I'm just going to go with these numbers because they're based on a study that we've conducted. So the question then is, where do we find these engineers? How do we train these engineers? Right, we know that whatever we generate, us as a community, we know demand is global. I mean, Len showed a great schematic there of all the projects he's working on. They're all over the world. And we want all these tailings facilities to be, adequate and continuously improving, so we're limiting, the threat to our society. So what we conducted another survey here at CSU a number of years back, and one of the key questions we asked was, when you entered the workforce as a tailings professional, was that in your intended path? And then everyone said no, they kind of fell into tailings. So the one thing I want to say then is, if we need more people coming into our industry, we shouldn't expect that they're just going to show up, because, I mean, most of us just came here by way of chance. So if we want to deliberately focus, right, we need to have a strategic focus on investing our time and money into grow that next generation. So let's develop this workforce. So I'll kind of go through these slides quick because I don't have much time, but you'll get the idea. So we need about 7,500 new engineers. Let's just take that as it is. We'll work with that number. I distributed that based on the same survey we had from before. This was presented at Tailings and Mine Waste last year. This was our distribution of people answering that survey. So I just took that distribution of doctorate, master's, and PhD and distributed that over the new engineers we need. Okay, so we're going to invest in these people, right? To basically want to pursue a career path. Investing in a bachelor student, maybe you get them having an internship, maybe a summer research experience, maybe doing active research in a lab, maybe you just provide them scholarships to get them interested. I said $10,000 for 2 years, right? That's pretty minimal. Master's student is about $75,000 a year, typically about 2 years for a master's student. PhD student is about $75,000 per year, about 4 years for a PhD student. You sum all those up, you get about $900 million, right? This is, again, it's just a number to put in the scope of an investment that you actually have to put into education to get people to pursue a path of interest. Okay, that's a lot of students. Who's going to train those students? So that was the next question I looked at. Well, in the United States, we have some certain groups that are interested and focused in growing tailings programs. In Canada, there's a number, obviously I've shorted here, but I said 6+. There's a lot of people up there working. Australia has a lot. Around the world, there's more. So what I said is I'm clearly don't have them all. So those of you, I saw that there's a really broad distribution on the line. If you know where are active tailings groups at different universities, definitely send them my way. I really want to know. So I took what I estimated and doubled. I say, well, let's assume there's 30 active groups. So now we have to distribute the engineers we need among those. So now we get to this number of different groups actively having programs that are growing engineers that are going to be moving out into the field to pursue careers in tailings. A quick check on if those are reasonable. At CSU, we've had a group of about 2 professors, starting at the assistant and moving up. And in the last 10 years, we've graduated about 40 students. Most of them are working in the tailings workforce. So we need to increase productivity about 4 times. So it's reasonable numbers, and we can do it. So you look at, can you invest in these programs, have the right people to move them forward? I believe that's all possible, right? You look at these annual graduation rates, APS, maybe, in the teens for MS, a few PhD, you can add those people actively to tailings and mine waste groups around the world. And I think with some faculty, about 3 to 4, you can really have a lot of productivity in these groups. So developing the engineers is going to take investment, both from a time perspective that we need to mentor and from a monetary perspective that we need to invest. We need focused investment, and we can grow this tailings workforce. So I say, let's invest and build the tailings workforce of tomorrow. So thank you, and we'll keep the show going. Yeah.
So I believe I'm next. Let me just share my screen. So hello everyone, my name is Klohn, and the aim of my presentation is just to briefly talk about the role of young professionals within ICOLD and what will be this year's activities. Just briefly about history, the idea of having young professionals group started to develop in 2009, and in 2011 the first official meeting of the young professionals happened during the ICOLD annual meeting in Switzerland. So we are 12 years old and we are trying to be as active as possible in these last 12 years. Our aim, well, our goal is to target professionals in the early careers and try to provide opportunities for networking, try to provide mentoring opportunities, and try to encourage young professionals to be involved in the ICOLD activities, to be involved in the activities of their national committees, and to be also involved in the work of the technical committees. Also, we are encouraging formation of the national young professional groups, and we are slowly growing this number. So just a little bit about the board members. There are 7 of us, and our term of office is typically 3 years. All board members are voted, and the election take place during the ICOLD annual conference, during the young professionals meeting. So the next election will be this year in June, where 2 terms will open, and 2 places for the new board members will be voted. The nominations are not open yet, but we'll open them soon and announce them online. The important thing to know is, if you're thinking about this, is that you have to have the support of your national committee, and that only 1 member per ICOLD member country is allowed to be on the board. So if there is already a member from a country on the board, then you cannot be a nominee. So there are over 100 ICOLD countries, and 31 of them have formed their young professional groups. The last one was Poland. Basically, just a few days ago, they formed their group of young professionals. We are encouraging the formations of new groups on the national level, and if you need any help, any support on this, you can contact us, and we are glad to help and assist in any way we can. And about the target events, as I mentioned, our main target events are ICOLD events, being the next one, the ICOLD meeting in Sweden. We're trying to be active online, for example, with webinars like this one today. We have some online meetings with the board and with other national representatives, and we run the LinkedIn webpage where we try to post the latest news from the field of dam engineering. I need to emphasize one thing as well, that this webinar, as also the previous webinars, are all recorded and they're all available online. So you can check our YouTube channel and look at the previous and this webinar later on as well. And just a little bit about the next ICOLD event in Sweden. The program for the young professionals, also the overall program, is very promising, but I'll emphasize some of the topics relevant to the young professionals. There will be a meeting for the young professionals with elections. There will be a networking event. Mentorship sessions will happen during the breaks. You'll have to apply for them, but just look at the announcements of the organizing committee and you'll find the notifications on how to apply. And also, as every year, there'll be a competition for the best presentation from the young engineer and for the best poster. I will conclude my presentation just by saying that you are invited to be involved. Also, one thing about these ICOLD events that usually young engineers do not know is that you can attend as observers also the meetings of the technical committee. So, for example, the Tailings committee will have a meeting during the next ICOLD meeting. And if you're interested in tailings, you can attend these meetings as observers and learn more. And thank you. That's all from my side.
Amy, could you share my slides, please?
Gerard, are you with us?
Sorry, Matara, I don't know if you can hear me, but my Teams is completely frozen. You might need to either someone maybe present my slides or skip over me. I'll have
Now
to try to
we can
rejoin
hear
the
you.
meeting,
We can
hopefully
hear
during
you.
the Q&A.
You can speak, we can hear you.
I don't
Okay.
think you can hear us.
Mateo,
Okay,
maybe
then,
go down to the next
then I
slides.
will say. So now we have concluded all the presentations and it's time for questions and the debate. So in the end, we would just like to show you a little bit of what are the publications available from ICOLD and from other resources regarding the tailings facilities. You can see them here written down, and where you can find some training if you're interested in the field. And also there are some conferences in the topic of the tailings, and here you can see the list of the conferences. I will leave this last slide as a background, and now we can maybe check the chat, or if you have a question, raise a hand and we will moderate.
Yeah, I've been monitoring the chat and I've yet to see any questions in there. I would like to have three things I'd like to offer to the team. So the 25,000 tailings facilities that we're seeing, or we believe is out there, that comes from work that was done as part of a research initiative in Canada, where we went through trying to understand a number of tailings storage facilities to try to establish what we refer to as the failure rate. We know the number of failures that have happened in the world in tailings facilities, and many of them have received high profiles. And when we interact with our friends in the hydropower industry or the water dams industry, there's a perception among our colleagues in those industries that we in the tailings field have a higher failure rate. And for a young engineer trying to decide whether they want to go into the tailings area or the hydro area, being associated with an industry that has a higher failure rate is less attractive. What we have done is improved that estimate of tailings storage facilities. So the failure rate is the number of failures that have occurred divided by the number of dams or number of facilities. So that denominator number is very important. So you can imagine if the denominator number was 2,000, as indicated in Madeline's presentation from the Global Tailings Portal, that failure rate would be very, very high. Even the 17,000 that Spencer had come up with, the failure rate is still pretty high. When we use 25,000, even 35,000, the failure rate comes down to about 1 to 1.5%. And that's almost identical to the failure rates that we've seen in water dams and hydropower dams. So the perception, the myth that tailings dam failures are more prevalent than water dam failures isn't true. So I wanted to share that with you, that's what's going in the background for that 25,000. So we have an initiative within ICOLD now where we're trying to actually locate those 25,000, and we have a database that has 11,000 facilities identified to date. And we know we are missing 8,000 for sure. Because in China, they have 12,000 alone, and we only have 5,000 of those 12,000 in our database. And we're missing all of Russia. We're missing a whole lot of other areas. So we're pretty comfortable that 25,000 is on. A second point I'd like to offer is we're working with the Society for Mineral Exploration in the United States on what we refer to as a training hub. We're in early stages there, but we're trying to create a website that pulls together all these things you've heard about in terms of training. Chris identified the 30 universities that are offering training. He asked for you to indicate whether there's opportunities happening elsewhere in the world, and there are. There's a group called the United Nations Economic Commission of Europe that does extensive training, which it wasn't in Chris's list. We know that there's training happening in Sweden. There's training happening in Germany. So we're trying to put this hub together that pulls together all this training that's available so that our young engineers, even our intermediate and senior engineers, can say, I'm interested in slope stability. They can go into the database and find where those training opportunities are available. So I think we're probably 6 months or a year away from having that database, but it'll be incredibly valuable. My last comment before entertaining discussion opportunities is related to the presentation by Madeline. Her presentation, Engineer of Record, was excellent. However, the Engineer of Record may be a bit foreign to some of you on the call. It's a little bit different than what you may see on a typical design project, where a designer will design an aspect of the dam, either the dam itself or a spillway or some component of a dam, and they turn over that design and the design gets built. They may be involved in the construction. They may do the as-built reporting, and that may be where their involvement ends. In the mining industry, the tailings world, we wanted to extend that concept to more of an ongoing supporting role. I think you're well aware that tailings dams and tailings facilities continue to evolve. Because of the nature of mining, a tailings dam may start at 15 meters high and then grow over time to being 200 meters high. So there needs to be this ongoing support, this ongoing continuous role, and that's where we have the engineer of record, which goes beyond the design. An engineer of record has to not just understand the design and just their specialty fields, say geotechnical, but they have to understand hydrology, hydrogeology, all the environmental aspects that Tamie described earlier, risk assessment, the closure aspects that were described by Fernanda, operations. They need to get an understanding of all those aspects, not simply the design. And it becomes quite exciting and quite interesting. Your learning curve stays pretty vertical. Mine is still vertical. After being in the game for 35 years, every day I'm learning fascinating things in hydrology and hydrogeology and geochemistry. But the fundamental thing that is pretty cool about the EOR is that I think many of us on this call want to fundamentally make a difference. We want to make a difference in the world, in the environment. We want to protect, people. We want to make the world a better place. We really want to make a significant difference. And as an engineer of record, you have that opportunity. It's like, unlike any other discipline I've seen, where you work as a partner with an owner in a mining company, and you're proactive. You're planning out 3 to 5 years from now of how that facility should evolve. You're identifying the risks. You're putting in all the measures necessary to do it safe and do it properly. And at the end of the day, you can go home at night and say, I made a difference. I fundamentally helped that client succeed, and I helped protect the environment and the people around us. So I just wanted to let you know that this EOR thing can be a bit overwhelming when you look at it, but it is a really cool career opportunity. So I just want to close off on that. There's one in the chat. May I suggest there's also an issue with enough developing or experienced persons for non-tailings dams? Yes, we're aware of that. And I'm not sure where the biggest growth is going to be happening. We in the mining industry, we see huge growth in mining to support the green energy, the whole green environmental sector. The search for precious metals are happening. Elon Musk, for example, arranged major deals with Vale to produce all the nickel they need to support their electric cars. Vale is ramping up significantly for production of nickel and cobalt. There's mining companies developing lithium and other precious metals. And those developments require significant tailings operations. But on the other hand, we see in India the massive undertaking of dam development projects in India for water supply, the same in Africa. So yes, I think as a whole, we have a dearth of dam professionals, and we're just trying to make it clear that the tailings opportunity is there for you as well. I don't see anything else in the chat, Jared or Matea.
No, I don't see any other questions in the chat as well. It looks like the presentations were very clear.
So maybe we can just go around to the Vito said not enough focus on mid-career professionals. Yes, that's exactly right. And Vito, this is where that training hub is going to be so important, because some of the training that's offered is geared towards intermediate professionals that kind of understand the stuff. They just want to learn more about the particular field. And the dam safety engineer, yes. In fact, when we were working on the engineer of record concept in Canada, we actually did it in concert with our hydropower colleagues, because they told us about how this concept of dam safety engineer exists. Now, in many hydropower companies, they have a large enough staff to be able to have dam safety engineers on staff. Mining companies don't often have large enough staff of geotechnical engineers and so on to have it in-house. So it's an external, and that's engineer of record, but it fundamentally is the same type of position. Humberto Aldana Martinez, we need to train people to solve technical current problems and challenges at the same time the industry is working to change the way we manage tailings, which should be the best approach to include both topics in today's training. Which should be the best approach? Oh, I see what you're saying. Yes. So yes, so we're talking about tailings dams and tailings dam safety and all that good things. I think the question is, are we moving to different technologies that actually don't use tailings dams? Yes. Len talked about the Greens Creek and the filter tailings there. We are seeing more and more companies going down the path of developing tailings facilities that don't require dams. But there's many, that's not all of them. There's production limitations, capital cost limitations, the properties of the tailings, the grind, the gradation of the tailings that prevent some of those technologies from being used effectively. So they're not going to fully get rid of dams. But yes, there are new technologies evolving that are helping to reduce it. Another ICOLD bulletin we issued 3 years ago was related to tailings dams technologies. That talks about
Andy,
exactly that.
if I can just jump in there with the tailings, thickened tailings and paste and all that stuff, filtered tailings. There's lots of challenges with those things. They're placed down, they're lightly consolidated. You've really got to understand the water balance and the seepage and the geochemistry, and they all have erosion problems, and most of them have small dams associated with them just for settling and water management and things. So I think there are as many problems with the filtered stacks as there are with dams. It's just the consequence of failure tends to be less, which is a good thing.
Yeah, well put, Len.
Yes, and on that note, it's Tamie here. Their ongoing environmental management becomes critical. So, yes. One aspect is making sure the dam stays up, and absolutely that's our priority. But then they have to perform to protect human health and the environment over these the decades of their operation. So those issues don't go away.
That's right. Yep. I guess, Jared, are you connected now?
Yeah, I hope so, Andy. Can you hear me?
Yep, good. Do you have anything that you'd like to share on what we've been talking about here?
I came in about halfway through that last discussion, so I'm not sure what the question was.
That's okay. I'll keep moving down the chat. There's a question here that's been provided in French. Are there training opportunities for French-speaking countries? That's a really, really good point. That is a gap. There's no doubt about it. In Canada, and the Canadian Dam Association, they have a commitment to bilingualism. And there is a Francophone committee that's been established. And they are asking that whatever training material we develop in English, that also is prepared in French. We're not fully there yet, but we are trying. In terms of the French countries that are dealing with tailings, such as in France doesn't have too much. They're doing some, but not much. And Africa, in the Southeast Pacific, we're not seeing enough practitioners there that are getting mobilized to participate in these things. If you have some suggestions on people from those countries that wish to participate in what we're doing at ICOLD to deliver training in French, we would be very much interested in that. We need more of that. And it's not just French. We also need to do it in Spanish and Portuguese and so on. Another question, it is necessary that the American and European universities also think about Latin American professionals. Here we have the same challenges and fewer training opportunities, yes. Yep. I guess the the webinars and the sessions that Chris talked about earlier, many of them are virtual. Chris, can you talk about, the worldwide audience you're getting for your sessions?
Yeah, I'd be happy to. I mean, with the two groups that are active in the United States right now, through Tailings and through the Tailings Center, we get a pretty good network of people. We've gotten a lot from Latin America, and a lot from Australia, mostly from North America, but I would say the predominant number from the Americas. There has been talk. I'll answer a couple other of these Spanish related questions. There is talk right now within the Tailings and Mine Waste Committee for SME here in the US to look at getting the new Tailings Management Handbook translated into Spanish. So there is some initiative there. It hasn't been done yet, but there's discussion. And I should say, at least in Tailends, we have the capacity to offer Spanish courses. Jorge Macedo, who's at Georgia Tech, obviously is from Peru, and I speak Spanish, so I've done short courses in Spanish as well. So there is an opportunity, and there will be more development on that in the future. So we do have our eye there, and we are active.
Very good. Yeah. A question here about how about the opportunities for geotech engineers? Do they have to have an experience related to mining works? And the answer is no. We are taking a lot of geotechnical engineers that may even just have foundation experience and trying to grow them into tailings dam engineers. They don't have to understand mining to move it. It takes time. It may take another year or two, but it's not a mandatory requirement. Does anybody else have a comment on that question about the geotech engineers? Okay, what kind of skills you expect from a geotech engineer who applies for role-related tailings management works? An understanding of effective stress is really good. Understanding contractive dilative materials is really good. Field work, sampling, being able to know what an SPT blow count means, what cone penetration tests tell you. They're very transferable skills. Does anybody else have a comment on the geotechnical transferability here?
I think that's exactly right.
Important to. Sorry, Len. I was going to say, Andy, I think it's important to keep in mind we all start somewhere. And like Chris said, we all kind of fell into a tailings career. So it's a matter of finding a topic that's transferable, and you kind of grow from there. But I'd also add the ability to work in a multidisciplinary team is really critical as well. So that's not specific to geotech, but something that you can bring and help you flourish in the industry.
Mm-hmm. Yep. Chris, did you have a comment?
No, I agree. I mean, I think they're very transferable, what you said, Andy. I mean, I think there's some additional training that needs to go along, but that's with any profession, right? You need to get on the job experience. But I think the geotech is a great degree to move into the tailings and mine waste area.
And a French question was asked, is it possible to train remotely? Chris described earlier the Tailings Center, Tailings, but all of the courses in courses in Australia are also offered remotely. And so this training hub, when we put it together, is going to indicate which of those are remote and which of those are in person. And even the in-person ones, many of them are hybrid now. Mike Jeffries is vocal in the need to introduce critical state soil mechanics concepts in undergrad and grad courses around the world. Yeah, absolutely right. We share the same comment. Oh, hello, Mauro. At least in Brazil, I noticed that more experienced professionals that graduated many years ago were not exposed to these concepts. Yeah, I'm going to share a personal perspective. I graduated in 1985. When I went through my undergrad, I was able to do 5 courses in geotechnical engineering. And when I did my master's, I did 6 more courses. But what we have seen over the evolution of engineering programs is a continued whittling down on the geotech. And you're lucky to get maybe 2 courses in geotech now, maybe 3 at most. So we truly are running into a situation where the undergraduates are not getting the exposure to what needs to happen to feed into this. And that's what these master's programs and the things that Chris is doing and UBC and so on are so critical, because we're not going to fill that gap at the undergraduate level. Anybody have any comments on that?
Yeah, Andy, if I can just jump in there. Certainly, I'm in the comments from Brazil, and we're very active there. And you know, critical state soil mechanics is a key part of designs these days. And you're right. You know, I certainly graduating in 1974. Whenever you know, I'd a small inkling that there was such a thing as critical state soil mechanics, but no training in it. And it's just another thing that you have to learn as you go along. And to Andy's point, you know, we're all still learning, and that's one of the fascinating things about the career that I've found over the years.
I guess Madeline is a young engineer on our delivery team here. What are your thoughts on this? Do you wish you'd learned CSSM in undergrad?
You know, I think a lot of the training is on the job, and especially as an undergraduate student, can be you're learning a plethora of information, general engineering topics, and personally, I believe learning to be an engineer is learning how to solve problems, and that makes the career very transferable across industries. And specialized topics such as critical state soil mechanics can be implemented in a career framework and be developed with like specific project basis. For me, I learn better that way. Some people are more textbook approach, but I'm a bit more application approached, and that's how things stick with me better. So that's just my personal opinion. I know others may learn differently, but I think facilitating learning for a variety of ways is important too, and understanding that not everyone learns in the same way. So
no, you're right.
a classroom setting isn't always as I guess it's not the environment that I learn best in. So
no, you're absolutely right. Enrique Perez put in a very interesting chart in the chat. I copied it over to a Word document here. I'm going to share my screen. Just one moment. Share. Yes. Yeah, this is fascinating, Enrique. This is a concern I think we've all had from a perception perspective, but to see it presented like this is quite concerning. What's in terms of the panelists, what are your thoughts on what is being presented here?
I'll speak like I said, as a non-engineer, but I see this in hydrogeology and geology.
Okay.
There, people are less interested in going into mining and oil and gas. And so what you're seeing in geotechnical engineers and engineering, we are seeing in other supporting technical areas such as geology and hydrogeology. Okay.
This is something that we've been talking about at ICOLD as well. What do we, and it ties into Matea's group, the young professionals. What do we need to do in terms of promotion, advertisement, communication to try to battle this? I guess Fernanda, Tamie.
Andy, can I say one thing on here? I think a big issue here though too is you know the perception of mining to younger folks as well. I mean, if we look at it here, I mean it's Colorado State University. We don't have a mining department, right? We talk about tailings and mine waste in civil and environmental engineering. But before we can start talking about that, we need to get students to change their perception on mining, because as soon as you say mining, right, they immediately have a perception of, oh, well, I'm more interested in, you know, something that's a clean job or something that doesn't contaminate the environment or something that doesn't tear up the ground, where I think they don't realize how much of the stuff they use in daily life comes out of a mine. And I think they need to just be educated, as you emphasized really well at the EOR role, but we go to all roles, of how big of an impact you can have that's positive in mining when society needs everything that comes out of the mine. So it's really on our, as educators, it's a lot on us to change that perception of students when they're entering the university, at 18, 19 years old. So then that when they get to thinking about their career, they think, oh yeah, that might be a good career path for me.
Yep. And about 5 years ago, I did a presentation to 60 very bright high school students here in my home. And I started the meeting with the presentation with who thinks mining is destroying the environment, not sustainable. And all 60 of the bright high school students, or 16 and 17-year-olds, put their hand up and said, yeah, mining is a horrible thing and destroying the environment. So then I did, as you said, Chris, I went through the discussion. Okay, here's where mining, the chairs you're sitting on, the phones you're using, the windows, everything around you. And then I went through the, at that time, the MAC, Towards Sustainable Mining Initiatives, what we're doing at CDA, ICOLD, and so on, and saying, here's all the great things we're trying to do to make this environmentally friendly and sustainable. And at the end of the presentation, I said, who among you thinks that mining could be done in a sustainable manner might be of interest to you? And 50 of the 60 put their hand up. So, Chris, it is very much just trying to get the message out that what we're doing is important. It can be done in a way that satisfies the values of our young people. But how do we do that is the question. What do we need to do? I don't have that answer, but we definitely need to get to that point. So thank you very much, Enrique, for presenting or providing that perspective. Yeah, okay. Yeah, there's... Does anybody have any other comments on that chart? Yeah, so there was a question in French here. You insist on a well-defined type of tailing storage when there's other types of storage. Yeah. Yes, there's other types of storages that can be accomplished, but it doesn't change the fact that they need to be done safely and protect the environment and so on. However, that's done. And so that's the overarching philosophy, is protect the environment and people. Is the location of mining site also a barrier to attract young professionals? Do we have anybody on the line that would like to pick up that question? Is the location of mining site also a barrier to attract young professionals?
I could probably jump on that, Andy. We have,
go ahead, Jared.
Sorry, Len. Seems like we always want to talk at the same time. Look, I surprisingly am finding no. We have a number of graduates that have come through our program in the last few years, and most of them actually want to work on site. Now, that's speaking only to mine sites that are like a 2-hour flight from home, and we bring them home every weekend. But it has been a positive sign for us. I'll let you speak now, Len.
Well, yeah, I was just going to mention the change in the sort of philosophy over my career from, the live-in sort of mining camp environment where there were families and, groups there, and now the FIFO. And, personally, I was lucky enough to be able to go and have a long stint at a mine site, and that was certainly a career sort of changing move for me. But I think with FIFO, it should be possible for people to have similar experience, but maybe not the social side.
Just to define FIFO, and I know what it means.
Fly in, fly out, sort of exactly. 2 weeks on, 2 weeks off, or 4 days on, 5 days off, whatever they do these days. I personally wouldn't have suited my personality. I much preferred to go and stay somewhere, but yeah, that's a big change over the last 50 years.
Yeah, we are seeing more young professionals want to have their weekends, more of the young professionals in the whole work-life balance discussion. And it is a bit tougher these days to have a young professional give up their weekends. But it comes down to how you communicate with a young professional. and how the value of what they're doing, and if it's part of a career path. So, people often talk about work-life balance, and they want to have work-life balance. So what does that mean? You're going to work 37 and a half hours a week and go to the cottage on the weekend? Is that work-life balance? Maybe that's what it is to you. I view it a bit differently. If you are doing things at your work that are helping you achieve your life's goals and your objectives, then that helps in your balance. If you're doing stuff at work that's not helping you achieve your life's goals and what you feel is important to your world, then you're not balanced. Doesn't matter what the ratio is of hours worked versus time spent at the cottage. So if you are working extra time, weekends, and the fly in, fly out, if you're doing those things and you see that it's helping you contribute to your overall path and growth as an engineer or as a person, then that's fine. Then the work-life balance can be achieved. But if your focus is to be home every weekend, well, that can start to tell your employer how committed you are to what you're trying to actually do. So it is an impediment, but it has to be part of the discussion with the young professionals of their values and what they want to do. Developing sustainable mining seems to be crucial to change the misconception. Yes, absolutely. How can the mining companies show that they care about the environment and want to protect it? David Maciano provided that. Dave, can you put in the chat which country you're from? In Canada, we have an initiative called Towards Sustainable Mining that those outside of Canada may not be aware of. It's an initiative by the Mining Association of Canada, and it focuses on 6 key pillars related to sustainable mining, which tailings is one of them: closure, greenhouse gas emissions, emergency response, and emergency preparedness, and so on. And the whole idea is to demonstrate in an objective manner that what's being done at the mining operations is sustainable. There are scorecards that are developed, and you have ratings that can be provided, and they're actually reported in the annual reports. And many mining companies that are now members of MAC are viewing this as part of the triple bottom line in the reporting to show how they are committed to the sustainable mining provided by MAC. I hope that answers that question. Further back up to Tamie's assessment of reduced interest in mining related degrees. Interesting. Yeah. Engineering physics, you would have thought was Sheldon Cooper. A lot of people would have been all over that. Oh well. Yeah, you're from Brazil, David. Okay, thank you. Yeah, so just take a look at the Mining Association of Canada Towards Sustainable Mining Initiative. Pierre Choquette, I find the chart is not that bad for the perception of mining. 30% of young talent we consider mining. This is actually way better than the actual enrollment in universities as compared to all technical. So there is just a little more convincing information to do. Okay, Pierre, thank you for that. We have about 10 minutes left, Matea. Is there anything else we'd like to do as part of the wrap up here? Or Jared?
No, I think it's only to thank everyone for their time, for attending, again to the presenters for giving you time. I had a few tech challenges, as you may have all figured out, and Andy and Matteo really stepped in to cover me. So thanks so much for doing that, guys, and hopefully it's made the event a success.
An interesting observation. I've been keeping track of participants as we've been going through this, and we held pretty steady till about 20 minutes ago. So that meant the presentations that were being offered seemed to be of interest to most people. So we were at about 120 to 130 people, and that was a very good cross section, Matteo. So thank you to you and your team for helping us get this message out. That you did a great job promoting it. Yes, we had great presentations, but if it wasn't for what you did, Matteo, getting the message out, this wouldn't have been very successful. So thank you for that.
Well, thank you for the initiative, and thanks, Jared, for organizing everything. And just to answer one of the questions, yes, the recording will be available, and so you can forward it to others who missed it. And yeah, 130 participants. I think that was the most for the webinars until now. So a very good topic. Maybe we should think about having another one. So yes, thank you, everyone.
Okay, have a good night. Have a good day.
Yeah. Bye bye.
Thank you.
Thanks.
Thanks very much. Bye.
Thank you all.